Hi, my name is Laniel D, and welcome to 60 Minutes, 5 Minutes Edition. And today we're here to talk about muscular dystrophy. What muscular dystrophy does is that the mitochondria get weakened and less effective, which means the muscle cells can't produce the amount of energy needed, and as a result, the muscles cannot effectively grow and function. Muscular dystrophy is caused by genetic mutation in which there is an absence of dystrophin, a protein that helps keep muscle cells intact. The disease primarily affects boys, but in rare cases it can affect girls. Muscle weakness can begin as early as age 3, first affecting the muscles of the hips, pelvic area, thighs, and shoulders, and later the skeletal muscles in the arms, legs, and trunk. The calves often are enlarged. By the early teens, the heart and the respiratory muscles are also affected. Most people will experience trouble in standing and walking. For furthermore information, we brought an expert, Dr. Swaus.
Hi, I'm Dr. Swass, here from the Muscular Dystrophy Research Facility, here to talk to you more about our disease, muscular dystrophy.
First off, what is a cell, and can you tell me how cells are related to muscular dystrophy?
Sure, a cell is a simple unit of life, and every living thing is either a cell or made up of cells. Cells are related to muscular dystrophy because in cells there's an organelle called the mitochondria. The mitochondria is essential for producing energy for the cell. Mitochondria are especially needed in the muscle cells, and since the mitochondria in muscular dystrophy are weakened, the muscle cells are unable to produce the necessary amount of energy required for the muscles to grow.
Second, why are organic molecules important in the disease?
Well, protein and nucleic acids are both important organic molecules for our body because proteins build and repair tissues in our body. And nucleic acid stores information that is used to make proteins and genetic information. Muscular dystrophy is also likely caused by an imbalance between protein synthesis and degradation. To elaborate, the rate of muscle protein synthesis is insufficient to replace the degraded proteins, making the muscle unable to grow normally.
Next, what is an enzyme and what does it have to do with muscular dystrophy?
An enzyme is a substance used as a catalyst to speed up chemical reactions. However, muscular dystrophy is not influenced by enzymes. As you can see, biochemistry heavily impacts the way muscular dystrophy works.
DNA contains our hereditary information. So how does DNA affect muscular dystrophy?
Muscular dystrophy is a sex-linked disease involving a mutation in the X chromosome. Thus, mostly males have the disease. In muscular dystrophy, the dystrophin gene code is disrupted by a mutation, which makes a protein that rebuilds the muscle work at a drastically lower pace.
Mitosis is a type of cell division duplicating the same number of chromosomes. Is mitosis also related to muscular dystrophy? Does replication affect the disease?
In mitosis and cell replication, the same exact information is copied, which means the disease itself is not affected. However, it just creates more cells that carry the effect of weakened mitochondria.
How are proteins made from the dystrophin gene in protein synthesis?
Proteins are made with some help from the RNA, which the mRNA will scan the DNA, transport it to the rRNA, and read the mRNA. Next, the tRNA brings amino acids, which builds up into a protein, and that's how every protein is made.
Can you explain what meiosis is and how does the disease pass off to its offspring?
Meiosis is a type of cell division that results in four daughter cells, each with half the number of chromosomes of the parent cell, as in the production of gametes. Since the disease is recessive, it is passed off to the offspring when the parents breed a female with two recessive alleles, or a male bred with one recessive allele on the X chromosome.
Can you explain to us deeper by using a Punnett square?
As you can see, the female is the carrier of the disease, but did not get affected because the other X chromosome makes it heterozygous dominant. The male is a normal, unaffected person. If the two people have a child, there's a 1/4 chance of being a female carrier, a 1/4 chance of being a homozygous dominant, unaffected female, a 1/4 chance of being a normal male, and a 1/4 chance of a of a male getting a recessive trait for the disease muscular dystrophy.
What kind of mutation is muscular dystrophy and what part of the genetic code gets affected?
MD is a mutation in the DMD gene. The DMD gene is responsible for providing instructions for making a protein called dystrophin. And MD is the result of faulty or missing dystrophin proteins, also classified as dystrophinopathies.
Thanks for the interview, Dr. Swaus. There are many people who have muscular dystrophy, but that does not stop from living their lives. Currently, there are no cure for muscular dystrophy, but treatment can help reduce problems in the joints to allow people with muscular dystrophy to remain mobile as long as possible. I hope this video helped you understand the disease and genetics as a whole. Thank you for watching.
Traes un poco loco, poquitito loco.
I'm just gonna add this in the bloopers. You singing Poco Loco.
Nah, no blueberries.